Cancer is a very smart opponent. It learns, adapts, and hides. But nearly every day, researchers find small cracks in its armor. Today, I'm summarizing 3 recent studies that show we're a little bit closer to putting an end to cancer for good. The first is a breakthrough for one of the deadliest cancers on Earth. The second, a treatment that involves using certain wavelengths of light to destroy cancer cells. And third, using time itself as a weapon. Welcome to the Goodish News channel. I'm Ashley, and I'm here to bring you non-depressing information that's also interesting. Hopefully. Pancreatic cancer is one of the most devastating, hard-to-beat cancers out there, and it has that reputation for a reason. Tumors often grow slowly with almost no symptoms until they're advanced. And by the time a diagnosis happens, the cancer has often spread or can't be fully removed with surgery. Standard therapy just doesn't cut it. So pancreatic cancer waits until it's winning before it lets you know it's there, which is a really cheap shot if you ask me. The survival rate is a pretty depressing number, just 13%. And for those diagnosed in the late stage, 3%, and that's being generous. Even when treatment slows down the cancer at first, it usually finds a way to adapt and comes back with a vengeance. But in this new study, researchers tried something more aggressive than traditional treatment. They used a combination of 3 drugs tested in mice with pancreatic cancer. Modern cancer drugs often go after one key protein that tumors depend on. With pancreatic cancer, one of the main drivers is a mutation in a gene that helps control cell growth. Block that signal and the tumor can, in theory, be stopped. The problem is, cancer cells are great at rerouting. They make Google Maps jealous. If you block one pathway, they're going to take a side street. So instead of just targeting a single signal, the researchers built a 3-pronged attack. Each drug in the mix hits a different piece of the tumor's growth machinery. On its own, any one of those drugs might slow the cancer a bit, but together, in the mouse models, they did something much more effective. Tumors stopped growing. But in many of the mice, the cancer didn't just stop. The tumors shrank. In fact, the tumors were completely eliminated. And those debilitating side effects that go along with standard chemotherapy, the mice didn't experience those. The treatment also cut off the cancer's usual escape routes, making it much harder for the tumor cells to develop resistance. In some animals, the disease stayed under control for as long as the study ran. Here's the reality though. This is still early stage work. All of this happened in mice, not in people. The real-world effectiveness in human patients is unknown at this point. A treatment that's effective in mice doesn't always translate to people. But for a cancer where the prognosis is almost always terrible, seeing tumors in animals actually stop growing and, in some cases, completely eliminated, this new method could at least offer a new angle of attack. It shows that for pancreatic cancer, the real breakthrough might not be one secret weapon, but a combination of drugs that hit the disease from several angles at once. Which brings us to another method of attack that also relies on combining tools. The next breakthrough in research involves tiny pieces of tin oxide and light. Researchers at UT Austin and the University of Porto in Portugal created ultra-thin flakes of tin oxide called nanoflakes that are just a few nanometers thick. That's tens of thousands of times smaller than a grain of sand. The idea behind it almost sounds too simple. First, the nanoflakes are delivered to the tumor. On their own, they don't do a lot. But throw some specific wavelengths of light their way, and things get a lot more interesting. Near-infrared light can penetrate several millimeters into human tissue, more deeply than visible light. When that light hits the nanoflakes, they go from nothing special to an active weapon. Once exposed to light, the flakes begin producing heat, which destroys the nearby cancer cells. In lab tests, this strategy killed about 92% of skin cancer cells and roughly half of colorectal cancer cells in just 30 minutes of light exposure. For a treatment that's literally tin flakes plus LED lights, That's a surprisingly great number. And to top it off, the same nanoflakes survived multiple rounds of activation. They didn't fall apart or lose effectiveness after one use, which means the same active weapon can be fired more than once. This fits into the broader idea of photodynamic therapy, which uses light to activate treatments. But this isn't your typical light therapy. Instead of a one-time drug that gets used up, these flakes keep working as long as they're in place and the light is applied. If future studies in animals and humans go well, some early tumors, especially on or near the skin, might one day be treated with something that feels more like a targeted light session than major surgery or full-body chemo. Conceptually, it could be a game changer. Load the tumor with nanoflakes, leave the rest of the body mostly alone, and then flip the switch only where the cancer lives. Who knows? Maybe someday this type of treatment could reduce the need for the most brutal forms of chemo. These two studies I've just covered have shown a lot of potential in lab settings, but they have a ways to go before we find out if they'll be effective in humans. But this final method of treatment is something that doesn't require years of clinical trials, and its simplicity is what makes it so great. The body runs on circadian rhythms. Those internal 24-hour cycles help decide when cells divide, when DNA is repaired, when hormones spike, and when organs rest. And tumors, surprisingly, follow rhythms too. Chemotherapy is usually scheduled around human convenience and hospital logistics. Is a morning slot best? Great. Are afternoons easier for the patient? That works. I'm gonna hold your hand when I say this. Cancer doesn't care what you have on your calendar. Research into chronotherapy asks a pretty simple question. What happens if treatment lines up with cancer's schedule? Cancer cells spend some parts of the day dividing rapidly and other parts trying to repair damage. Healthy cells also have active and resting phases. If chemotherapy strikes when cancer cells are in the vulnerable dividing phase and at a time when healthy tissues are in a more protected state, the same drug at the same dose can hit the tumor harder and the rest of the body less. In some clinical studies, patients whose chemo was timed to their body's clock had better tumor responses and fewer side effects than those who received the very same drug at random times. This is especially interesting because it doesn't require designing a whole new class of medicines. It's about taking the tools that already exist and using them more strategically. In the long run, chronotherapy could become highly personalized by matching treatment times to each patient's circadian rhythm. The timing of treatment stops being an afterthought and becomes part of the strategy to beat the disease. Cancer is still a brutal, complicated opponent. There's no single drug, special treatment, or scheduling trick that will solve it alone. And let's keep in mind that every patient and their genetics respond differently. But I want to end on one hopeful stat. The American Cancer Society just reported that the 5-year survival rate for cancer patients is now up to around 70%. And some of the biggest gains have come from cancers that were once considered to be almost untouchable. Using combinations of drugs, new therapies, and more personalized treatment plans means the Cancer Playbook is getting bigger. And that gives us a real chance at winning the long game. If you're looking for more good news in your life, be sure to check out this video right here. And if you enjoyed this video, please give it a like and consider subscribing so we can ignore all the bad news together.